Section 3 of, or excuse me, day 3 of section 6 in chapter 3, solving compound inequalities. Today we're going to kind of put together the ands and the ors, and then we're also going to talk about some special cases. So remember, we're going to combine and and or today. So on the and compound inequalities, we need to shade in the middle and make sure that our answer is written as a triple. Whereas the or inequalities, we shade on the ends, and then we just write our answer using the word or. Excuse me. So number one, just to review, solve each compound inequality in graph. So what you should first do is decide, is this an and or an or inequality? Hopefully you're saying and because it's written as a triple. And when we solve the and inequalities, we want to isolate the variable in the middle, but we need to do subtracting 5 all three sides. So we get -2 is less than or equal to x is less than 0. And now we want a graph. And I didn't put the graph on here today, so I have to draw it myself. So we're talking -2, we are including it. 0, we are not including. Less than or equal to, and just less than. And it's an and inequality, so we want to talk about the values in between the 0 and the -2. And logically, you can see that as well. It's x is greater than or equal to -2, and it's less than 0. So we want greater than -2, less than 0, we're in the middle. Here we have obviously an or inequality, compound inequality, because of the word or there. So what we typically do is just solve both of those, but you'll notice that they are already solved. So now we just need to graph. We're talking about values that are less than 1, so that's to the left of 1, and we are greater than or equal to 3, so that's to the right. So that's a pretty simple review of an or and an and inequality. Just remember, the shading on and is in the middle, and the shading on the or is on the ends. So let's talk about some special cases, such as what happens when all of the line is shaded, or what happens when none of the line is shaded. So we're still solving the inequality and graphing. So let's treat this just like a regular or inequality where we solve each one individually. So we add 2 to both sides. We get x is greater than 7, or here we have subtract 5. We get -3x is less than -9. Divide both sides by -3. That's going to flip the inequality. So we get x is greater than -9 divided by -3 is 3. So this is an or inequality, so typically we shade on the ends. But we need to be careful that we're still paying attention to the symbols. So here we have greater than 3 or greater than 7. So if we just kind of shade lightly, the first inequality, greater than 7, we'd be out here. But the second one says x is greater than 3. Notice we had to flip the symbol because we divided by a negative. Well, values that are greater than 3 are also to the right. Notice we shade in the direction it points, and that would also continue on past the 7 because those numbers are also greater than 3. So then the question is, how do we actually graph this? Well, the answers here would just be all the values that are greater than 3, since the values greater than 7 are included in that. So here we're going to kind of darken this up a little bit. And even though it is an or inequality, we had overlap, so our answer is just x is greater than 3. We don't have to worry about saying x is also greater or x is greater than 7 because that's included in the x is greater than 3. So if you have some overlap where one value overlaps the other, you only have to write one of them as your answer. Let's look at another one. We still have an or inequality, so we want to solve each one individually. So we have x is greater than 3, or if we add 4, we have x is less than 3. So let's look at the first one. We have the number 3. We're talking about all values that are greater than 3 this way. And it's an or inequality, so remember they don't both have to be true at the same time. So then we also have x is less than 3. Well, that goes this way. So we basically shaded the entire graph. But what I want you to notice is that there is something on the graph that has not been shaded. What has not been shaded? And hopefully you're saying the value 3. So how do we write this as an answer? Well, we can say all real numbers and we can say x does not equal 3. So that means every other answer will work except x equals 3. So all real numbers, but x does not equal 3. And let's look at one final example. Here we have the and inequality, and when it's already split up like this, you're going to go ahead and just solve them separately. Notice here that the 4x minus 5, 4x plus 5 aren't the same anyway, so we don't want to combine it as a triple. So we just add 5 to both sides. So we have 4x is greater than 20. Divide both sides by 4, and we get x is greater than 5. And now we have 4x, if we subtract 5, 4x is less than 10. And divide by 4, we get x is less than 10 over 4. That reduces to 5 over 2, or 2.5. Now remember, this is an and inequality. When we work with and inequalities, both parts have to be true. Remember, it's always the overlap that gets shaded in the middle. So I'm going to write the two numbers here. 5 halves, we're not including it, and 5, we're also not including it. But notice which way the arrows point. This one on the left is indicating that we would want to shade this way. However, the one on the right is indicating that we want to shade this way. So if we're talking about an and inequality, what you need to ask yourself is, can a number be less than 5 over 2, or 2.5? Can a number be less than 2.5 and be greater than 5? And the answer to that is no. So on an and inequality, when we have no shading that overlaps, this is an indication that we would say no solution. So we write no solution. And you need to make sure that nothing on your graph is shaded, because when you shade on a graph, you are indicating that there are solutions. So no shading on the graph. I did leave the circles open like I was supposed to, so again, that doesn't mean we're including those numbers. And we say no solution. Remember, again, with an and inequality, it has to be where they overlap. It has to be true. A number cannot be less than 5 over 2 here and greater than 5 at the same time. So no solution. So we've looked at some special cases and reviewed the and the or inequalities. In class, we'll work on worksheet 3.6c.